And I go to the next slide. So how many significant figure? 2. How many here? 4. How many sig fig? In this case, this is not significant. Not significant. So only 3. How about here? Powers often are not counted for significant figure. It's the coefficient of scientific notation. It shows number of significant. So only 2 significant figures. Now zeros after a digit could be significant or not. Normally assume they are not. Because you don't see the tool of measurement, you can't be sure. It could be a placeholder. So can I say this has got only 2 significant figures? In other words, if I were to write this, would you write 5.6 times 10 to the power of 2? So 2 sig fig. If I write this one, can I write scientific notation 56 times 10 to the power of 4? .6 I meant. Times 10 to the power of 3 I meant. Sorry about that. So 5.6 times 10 to the power of 3, it still has 2 significant figures. So these zeros not significant. Assume they are not significant. Zeros which come after a digit. Could be and could be not, depending on tools of measurement. If you see the tool of measurement, you see the accuracy, you can accept it. You can assume they are significant. Suppose you're getting this number from a balance which has accuracy on 1 gram, then you can say all those zeros are significant. But that's not the case that usually appear on scientific papers. If I meant to say I have a balance which has accuracy on 1 gram, all I have to do, write this, 56, I put a decimal point here, grams. Then you know these are significant because I have a decimal point here. All right, go guys. What do you think? Which one of these have got 3 significant figures? Go ahead. So you see if you got the answer. Does this make sense? 3 significant figures. These are not significant. How many here? 4 sig fig. How many here? 4 sig fig. The 0 is after decimal point, after a digit. It is significant. How many here? Just 1 sig fig. The 0 is before a digit are not significant. How many here? 3 sig figs. How many here? 4 significant figures. These 2 are not significant. They are zeros before a digit. Do I make sense? If it doesn't make sense, write it down. Come and see me. Go ask Annie during the discussion class. Ask a tutor. Make an appointment with science learning tutors and ask questions. Go to YouTube and check under significant figures. Lots of videos there. Lots of resources for you. Okay. Which of the following number contains 4 significant figures? How many here? Assume this is not normally. Not significant. So can I say 5? How about here? Well, this is significant. So 1, 2, 3, 4, 5, 6 significant here, figure here. And here, did you say 5? And here, 2, 4, 6. And here, 4 significant figures. Are you with me? Make sure to come and see me if you have any question. 4 significant figure, that is the one. And if I go to next slide, guys, do you remember when you are doing a calculation which is involving measurements, we have to come up with the right significant figure for the answer. That's very important in science and engineering. Suppose you want to add these two measurements. Suppose these are meters and meters. In other words, there must be a unit if we have a measured number. If you add them together, this is what your calculator shows. But is this the correct, reliable answer for us? What is the rule for addition? Do you see, I don't know what is this digit here, what is this digit here? In other words, this has uncertainty in it. This one has uncertainty in it. So only this one is reliable. So I look at number of decimal places. Is this one decimal place? And how many decimal places here? 3 decimal places, yes. So choose the minimum decimal places, not minimum significant figure, minimum decimal places. It means your answer should represent this least accurate one. That means you should have only 1 decimal place, because these other 2 numbers are not reliable because we don't have any accuracy here. We don't know what's the digit is coming here. The same rules apply when you are doing subtraction. Look at number of decimal places. Can I say 2 decimal places here? How many decimal places here? 4 decimal places here. What is minimum between 2? What is the smaller between 2 and 4? 2. So once you get this answer, round it to do 2 decimal point. Delete these. The first digit I'm dropping is more than 5. I add 1 digit to previous number. So 0.79, there must be some sort of unit. Suppose there is a unit here. I didn't write the unit here because it can be any measurement. It could be grams, or it could be meters, or it could be milliliters, any units. All right, again, we have done this in Chem 2A. Do you remember what our rule was about multiplication? Significant figure in multiplication. Well, you determine the significant figure of values which is being multiplied. Your answer must show the minimum significant figure. How many here? 3. How many here? 5 significant figure. Which is the smaller between the 2? 3. So my answer must be rounded to 3 significant figures. This is 1, 2, 3. I drop these. I look at the first digit, which is being dropped. It's less than 5. Ignore it. So 15.6. What if I had this 16.5? Let's say 6, 6, 3, 3, 6. So I had 3 significant. If this was here, I have 3 significant figures. I cancel these. Look at the first digit drop. It's larger than 5. So the answer is going to be 16. Point, can I say 7? whatever the unit is. Why? Because I'm dropping, the first digit I'm dropping is larger than 5. The same rule applies to dividing measured numbers. Look at number of decimal points. There are 1 decimal place. Here, there are 2 decimal places. Smaller number is 1. My answer should have only 1 decimal places. I beg your pardon, I'm sorry. Let me correct myself. So can I say your division is just like multiplication? How many significant figures here? 2. How many significant figures here? 5. The answer must have minimum. So I must have, this is the result calculator show you. So I must have only 2 significant figures. This is not significant. 1 significant figure, 2 significant figure. I'm dropping the rest. I look at the first digit that I dropped. It's larger than 5. I add 1 number. So 0.061 is the answer. 2 significant figure. This is the most reliable answer from this calculation. Make sure to come and see me if these do not make sense to you. If the digit that you are removing is less than 5, round down, that means ignore it. If the first digit that you are removing is greater than 5, you round up. What if the first digit you are dropping is 5? You look what is coming after. If the following number are non-zeros, they are digits, round up. If you're dropping 5 and the following number is 0, round down. So this is a little different from Chem 2A because you are taking a course in science. Chem 2A was introduction to chemistry. This is the first chemistry, general chemistry is the first chemistry you are taking for science majors. So we are being a little bit more detailed and more accurate.